not. Because this is to get you starting to think about what I'm going to need your brain to be at during the lecture. If you got it done, great. If you don't, as long as you're working towards what I want you to be, that will be fine. I'll measure if you get this right or wrong when you guys take your quiz next week or Wednesday. Do you understand? And I'm not trying to pick on you, Elena. I just want to know that you're not punished because you didn't get it all done. You're punished if you just sit on your cell phone, because if someone's on their cell phone, I just go nuts. Please understand, I take my trig lectures extremely serious. You may not believe this or not. And if you don't, then you need to talk to my wife, Kathy. Because there was one time that I was teaching a trig lecture, and she came in the back of my classroom right back there. I never saw her, never looked up at my paper. She called my name out 3 times, still never heard her. Never saw her, never responded to her. When I got back, she told me she was in there, and I never knew that because I am doing my lecture and I do not want to be distracted by nobody, even if I'm married to him. Any questions? If you don't believe me, ask. You can go ahead and ask Kathy. That is 100% true. No, Matt, no. Let's just get it up.
Is that your pencil?
Anybody know the answer to number 1?
Oh, 4.
Elena.
4.
Because it's a 3, 4, 5 triangle. Any questions? No? Good. Anybody know what X is and what Y is? Greg.
Y is 3, X is square root, or 3 square root 3.
Can you please tell me? Well, I'll get that down there. Number 3. What do we know about the X and the Y? They're going to be equal, correct? So, what is it? What do you think, Emma?
1 over the square root of 2.
Yeah, correct.
Okay. We'll visit that in a minute. Yeah. Okay, so what is the general rules for solving a 30, 60, 90 degree triangle? Shauna.
The hypotenuse is going to be twice the length of the short side and
Okay, so the short side, 30 degree side is hypotenuse divided by 2. 60 degree side is what? Go ahead, Shauna.
using your what we've already decided, it would be the hypotenuse over 2 times the square root of 3.
Triangle. 45, 40, 90 degrees. What do we know about that? Carson.
The 2 like short sides are the same.
Okay, good. How do we figure out what the short sides are?
What is it? Non-hypotenuse.
The hypotenuse. And that doesn't matter which leg it is. That's either leg, correct? Good. Because these are going to be very important for me when we build our unit circle. What's your question?
So if it's the 30-degree side, does that mean the short side? So does that mean? So does that mean X is the short side of your triangle?
No. X has to be the large side because it is opposite the 60 degrees. And the angle, the opposite side of each angle is going to reflect on where it falls in the hierarchy. So if I have a 60-degree angle, then the opposite side of that has to be the bigger side. If I have a 30-degree angle, the opposite side has to be a shorter side. Okay. Good. That's the first start here. Now, someone said wait.
Do you like look at your accent?
Now here's the other thing about trigonometry. I do my lecture on these scrap pieces of paper. When I'm done with my lecture, I actually clip it on the marker board over there. So if you miss, you need to get caught up, you can go ahead and just grab the copy and always have the notes that I use. You understand that? This is my notebook for teaching trig right here. These are the notes I've taken just for teaching the trig, not including the homework. Okay. That will come back to haunt us somewhere in this lecture. Not right away, because there's another concept I really was frustrated with that I felt CPM did you guys a disservice to get you ready for. So if you guys understand it, others do not. How many degrees are there in a circle?
360.
360 degrees. What's the circumference of that circle if your radius is 1?
IR. No.
Just 2 pi, right? Does everybody understand that? Formula is 2 pi times the radius. If the radius is 1, 2 pi times 1 is just 2 pi. I can divide both sides by 2. 180 degrees is the same as pi. It's halfway around the circle. If I start here and I go my angle, like you're looking at a clock, if I move my arm halfway around, I moved it 180 degrees. Which you guys studied way back in geometry, right? A straight line is 180 degrees. We should know that. Well, if I start with this angle and it's going to be 2 pi all the way around, halfway around is 1 pi. This is important for our converter. Degrees, pi. 180 degrees is the exact same thing as saying 1 pi when we are working on the unit circle. Converting something from degrees to radians. You're going to take your theta, times it by pi, and divide by 180. Why does that work? Because we just said 180 is the exact same as pi. So this is really just 1, isn't it? 1 over 1? Because they would cancel each other out. But this would just give it to me in the wrong units. Radians are measured in 2 different ways. They'll either use the word rad, or they have a pi symbol. What does theta refer back to? The angle. Don't say that it refers back to degrees. It refers to the angle. In this case, the angle was measured in degrees, so I had to move it to radians, but it's just the angle. Radians to degrees. Now, degrees should be with that little circle up high, correct? So once again, theta times 180 over pi. What did I do? I just flipped the fraction. Degrees to radians, pi's on top, 180 is on the bottom. Flip the direction, radians to degrees, all I did is flip my fraction. Questions on that? Good. When I give a symbol like that, that means I'm not changing my thought process. I'm no longer talking about something you want on your note card, okay? In fact, we're going to do an example of this math. You had a test question yesterday. A lot of you guys got it right. Very few of you understood what you did. First thing said, draw 5 degrees. You guys remember this question now? Draw an angle that's 5 degrees. Most of you guys, I would expect, would be able to draw an angle and say it was 5 degrees. Am I correct? You should have been able to do that much. Okay. Then, it asks you to draw something in 5 radians. Radian. Radians means radius. We're dealing with the radius, that's why they use the word radian. Radian, radius, radius, radian. They have to deal with each other. But we have no idea how to break up 5 radians. We've never broke it up before. But we have done degrees. So I want to change my 5 radians to degrees so I understand what it's asking me to do. How do I do that? Go back up to this handy dandy converter. What's my theta? 5 times 180 divided by pi. So if you did this, you should have 5 times 180 over pi. Questions? If you type that in your calculator, you should get somewhere around, I'm going to say 283 degrees.
286.
Yeah, 886.
Oh, I forgot to carry the one. Thank you. 286. Didn't think that was too bad doing it in my head. What does that mean? Bracket. Yeah, that's right. That means I'm going to start right here, like I'm on a clock hand. And I'm going to rotate my clock hand all the way to 286 degrees. If I remember your test question yesterday, I asked you, are those two are going to be the same? No, not at all. How do I know that? Well, I can figure out this is just in the first quadrant, that's in the fourth quadrant. Obviously, they can't be the same if I just look at that piece alone. I'm not exactly sure how, but somehow CPM thinks you guys understood that.
Nope.
Okay. I am going to give a problem. This is the next thing I do. I am going to walk around to every single person and make sure you did this problem correctly. It is going to be based off this notes. Because the second part of the question was, how many radians is 5 degrees? Please start figuring that out. I gave you transformers right away. What do you got? Okay. Okay, reduce. What do you got? You don't know if you're perfect. Now you either reduce the fraction or you type that in the calculator as it's written and give me the number that pops out. It's set up perfect. You got your theta, you got your pi, you got your 180. Just type it in. Or you can leave the pi symbol in there if you want to, but you still have to reduce 5 over 180. Any questions on how you do that? You feel confident right now because you convert from radians to degrees? As long as you have the converter. right, thank you for the fist bump. That's right there. That's what you do. What do you got, Cam? There you go.
Wait, can I get a dab up?
Then you got it right. You helped. Hey, I got a different answer than every one of you guys. Because you guys almost got the whole answer. I saw a lot of .087s, correct? But your real answer is .087 rads.
I put rad.
Now, here's what I put. See if this makes sense to you. Yeah.
Did you just do 5 divided by 180 and then you put the pi on the bottom, 5 divided by
I just reduced the fraction. Which is the exact same number you got. Now, sometimes you saw, give me the exact answer for, correct? And you guys typed you got .087. Well, that's not the exact answer, that's rounded, right? Well, you can go read all the way to the last number, and guess what? That's still not the exact answer because it's rounded. Why?
Because it's irrational.
It's not in radians.
Pi symbol is irrational. It never ends.
So by anything, it's still gonna be irrational.
Huh?
Because if you divide or multiply by anything, it's still gonna be irrational unless
That-
you're dividing by pi.
That's right. So you guys got an approximation. I can say I got the exact answer because I left the pi in it. Potato, doesn't matter. I just want you to be able to see both. Okay? Good. So, degrees to radians, radians to degrees. At this point, I expect you to be able to do that by yourself. In fact, on 356, 17 to 24, you have 8 problems. All it's asking you to do is change it from degrees to radians, radians to degrees. No, let me take that back. It's in radians, you gotta change it to degrees. That's it. Yes?
Are the assignments going to be in Schoology too?
No, they are not. Do you need me to?
Yes.
I'll be happy to.
Okay.
Now, speaking of which, you guys are wondering where the heck am I supposed to look up? I did email you guys each a PDF copy of the textbook.
Okay.
So you have your own copy. We are building our own unit circle today. I am going piece by piece, showing you how the numbers got there. You guys are going to explain the numbers, and you're going to understand what the numbers mean. I gave you a cheat sheet the other day, and I don't think you guys even had a clue what it was. You just used it as a cheat sheet. So it's time to learn what it is. Okay. We are going to fill this sheet with a ton of information, so you're going to want to be able to keep this straight. Personally, I need 3 colors just to keep myself straight. If you guys want to, I have red and purple pens up here for you to borrow. I have black ones in there if you need to. If you have your own, that's fine. If you don't need color, don't use it. I don't care. So orient this sheet. There should be a line with a gap. That means that's the top. Line with the gap at the outside of the circle is the top of the circle. So that is how this is going to be oriented. As Kevin is my witness, when I teach trig, I teach you how to do this unit circle in September, and you're still using it in May. It needs to be durable. So I'm going to give you guys an option. On Friday, at the end of the day, if you would like to put your unit circle in my laminating folder, I'll have it laminated so it will hold up longer for you, because if I teach trig next year, you'll be able to use it on every single test. When you get to calculus, you have to memorize it. But until then, I want you to know how to use it. Questions, comments, concerns? No? Good. Let's move. First thing is, this is called the unit circle. That's the title of it. It has a radius of 1. That's the definition of a unit circle. The radius must be 1. This is a circle making triangles on a Cartesian plane. Cartesian plane is broken up into 4 pieces. 1, 2, 3, 4. Does anybody know what those pieces are actually called?
Quadrants.
Quadrants. Why? Quad 1. Very good. Now they do a little bit different type of information for this. They actually write it in Roman numerals. I am actually going to put right here. This is quadrant 1. This one's 2. Three. And 4. Some people don't realize that 4 is really just IV. Alright, I'm going to start off with general rules of quadrant. We're going to get more specific, so I'm going to have 3 general rules. So I do this in black, and I go all the way around, so that I can fill the color in a minute. So, basically I'm just putting 3 brackets with a line in the middle. I will fill that in a minute, but I'm doing it in all 4 quadrants. I want to make sure you understand this. Notes on separate pages is not going to a unit circle. Unit circle is almost like a note card, okay? You want to keep this? That's fine. If not, I just want you to understand this. You guys have known SOHCAHTOA forever now, right? We are going to be dealing with right triangles on the unit circle, which means the right triangles are always going to start at the origin, and they're going to go out, up, or down. On your graph, what axis is this? What axis is this?
Y.
Every single time. And what's this?
Radius.
It's the radius, isn't it? We're on a unit circle. Okay. So here's my question. What's the definition of cosine from SOHCAHTOA?
Adjacent over hypotenuse.
Adjacent over hypotenuse, is that correct?
X over Y.
Which is adjacent over hypotenuse, correct? Which is really x over, what's the hypotenuse? The radius, right? What's the radius on a unit circle?
1.
What does cosine theta equal on my unit circle?
X.
What's the definition of sine?
Opposite over hypotenuse.
Can anybody fast forward to what the final definition
Y.
is going to be? Why? Does everybody understand that? Perfect. In a natural coordinate system, I have x and I have y. Is that correct? It's a coordinate system, x and y. When I give you a point, and if I say 2, -4, you should know to go 2 to your right and down 4. Does that make sense? What is x in the first quadrant? No, I want to know positive or negative.
Positive.
Positive. What's y in the first quadrant?
Positive.
what did I just say x equals in that trig terms?
Cosine.
What does y equal?
Sine.
Sine. So cosine and sine are gonna have the exact same behaviors as x and y would have in that quadrant. So, let's take a look at this in quadrant 2. Now, because I don't like dropping my pen after every time, I'm gonna just go straight down. What is the first thing here? The first part of a point? We should know. It's x. What is x in quadrant 2? Negative.
Yeah.
If x is negative, what's the other term that's related to x that we're using from trig? Cosine.
Or is it still just cosine?
It's just cosine. So cosine's going to be negative in this quadrant. Please pay attention. Negative is a direction from now on. It's not
Value.
a value. It's not a measurement. It's a direction. The other term is y. What is y in the second quadrant?
Positive.
Positive. What trig term goes with y?
Sine.
Sine. I'm going to continue with the purple because it's already in my hand. I already know it's y. I already know it's sine. You should have that. That should be automatic. Y, sine, sine, y. What is it in the third quadrant? Negative. Very good. X. X goes with cosine. We know that. That should be beaten into us. What is cosine in the third quadrant? Negative. Anybody brave enough to tell me what sine is in the fourth quadrant? I said sine. Please pay attention. Huh? Negative. And what is cosine? Positive. Okay, so that's the first start of my thing. There will be questions on your homework. It will say, if cosine is 130 degrees, will it be positive or negative?
Negative.
Second
Well-
quadrant,
This is what, 0?
Positive.
Yeah.
That's 90? That's 180? Where would 130 fall?
Between those two.
In the second quadrant. So what's cosine in that quadrant? Negative. Don't overthink the problem. Just tell me, is cosine negative or positive when I give the number? What is sine at 359 degrees? What quadrant would that be in? It'd be in quadrant 4, so it would be negative because down here it says quadrant 4 sine is negative. Is there any questions on this? So let me see if this makes any sense to you guys. That's 0 degrees. I do black on this one. This is 90 degrees. This is 180 degrees. And this is 270 degrees. Is there any questions on that? No? Yeah.
So just make sure 360 is the same as 0 degrees.
Correct. In fact, the term coterminal is something you're going to learn later, but yes, this is actually also 360 degrees. How many radians is 0 degrees?
0.
0 pi. So I made the pi symbol really small. I should have made it bigger. But 0 pi because 0 times anything 0. Who can tell me how many radians 180 degrees is? Bracket. 1 pi. Emma O. 0 pi. 1 pi. What's 90 degrees? Thank you.
Pi over 2 or 1/2?
Pi over 2, 1/2 pi. Can anybody tell me what they think 270? Yeah, go for it, Izzy.
3 pi over 2.
Why would you want 3 pi over 2?
Well, try this by halves, right? 0 halves,
Oh, yeah, no.
1/2, 2 halves, 3 halves, 4 halves. Perfect. Yeah.
What was like 90 degrees? Would you want it to be pi over 2 or could it be 1 over 2 pi?
I like a pi over 2 just because I want to write the extra 1. Does everybody understand this? Okay. If you understand this, here we go. Cam, I'm creating an angle right here. Halfway between 0 and 90 degrees. What would that angle be?
45.
How'd you do that, Cam? I didn't see your lips move. Yet I still heard the dummy. 45 degrees. Now the question is, how many radians is that, Brecken? The softball player, Brecken.
Half of half.
Very good. What's half of half? 1/4. Do I need to show you guys with the converter how that works? 45 degrees times pi over 180. Reduce the fraction, 180 over 45. 45 goes into 180 4 times. So not only did she do it by visual, which she did, I can mathematically prove that she is correct. Questions on that?
Are like the thing that you just made, like, I'm just confused on the symbols. Like, is that one where it says 45 degrees, that one's pi?
45 degrees outside the circle is measured in degrees. It is the exact same thing as me saying pi over 4, which is measured in radians. That's why I put it inside the circle. All the radians I'm keeping inside the circle.
Does it make a difference if you make the squigggle line?
No.
Oh.
Just don't make this symbol because we don't know what it means.
What is that?
We don't know.
We don't know. All right. Can anybody give me this angle? In degrees.
135.
135. How about in radians?
3/4? Yeah.
Pi over 4.
Dang it! You have any one now? Thank you. Never mind, got it.
Okay. Any questions about how we get those angles? No? Good. $30 degrees. Pi over 6. It's 1/6 of it. Because 30 is 1/6 of 180. Perfect. Now, time for the next step. You guys remember your warm-up?
Yeah.
Remember rules I asked you? Good. I just said what marker did I just put on my unit circle? 30 degrees. That means if I did that a little bit. If I graph a line at 30 degrees and I take a point and I drop it straight down to create the right triangle here, that's my y. That makes that my x. Why? Because this is on the x-axis, that's going up and down. Who can calculate what my y is? Using that rules, if we remember, the radius for a unit circle is 1. What is my y?
0.5.
I heard 1/2.
Same thing.
What you get before my x?
Square root of 3 over 2.
Square root of 3 over 2. Does anybody have any questions? I figured out those two sides of the triangle.
Yes, hold on.
That's just from our rules from the unit circle. Okay. This is a 30-degree triangle. Right here. It's a point. Right here. What's my x? We just calculated right below. Elena?
Square root of 3.
What's my y? Played it? I have. So, on my unit circle, and if you guys remember that little sheet you had, and you had those numbers, you probably had no idea where those numbers even came from. Well, it actually just came from our triangle map. So I said to Leah, what is the cosine of 30 degrees? I would expect Leah to find 30 degrees on my map, and then tell me, is the cosine going to be the first number or the second number of that point? So what is the cosine of 30 degrees?
Square root of 3 over 2.
That's the answer. The cosine of 30 degrees is the square root of 3 over 2. I should be able to go to Addie and say, Addie, what's the sine of pi over 6? 1/2. Why? Because pi over 6 is right here. And why? Purple plus 1/2. Any questions on that? Okay, good. So that's 45. That tells me that we are going to be drawing a 45, 45, 90-degree triangle. Do I have my colors back? I do. This is purple. I call it Y because it's up and down. And this is X. Back up. Radius is still 1. What's the size of Y?
1 over square root of 2.
Questions on that? Carson, we know a 45, 45, 90-degree angle is isosceles triangle, which means what? So what's X?
1 over square root.
Very good. Now I said this before and I said it again. You have a problem. You can't have a radical in the denominator, so we gotta pick it. There's two ways of picking it. You can do Mrs. Utek's way, or you can do my cheerleader way. Here's Mrs. Utek's way. If I remember correctly, she taught you guys to use 1, which means you're gonna multiply it by itself over each other, right? And you get the square root of 2 over the square root of 4. What's the square root of 4? Any questions on that? That's the Utek way. The senior way. And you're gonna have to repeat it in a second. senior way is bump, bump, bump that radical up. Keep that base. Try it with me. Bump, bump, bump that radical up. We're gonna try again. Ready? Bump, bump. We're gonna keep doing this until Addie repeats. Bump, bump, bump that radical up. Keep that base. Try one more time, Addie. Bump, bump, bump that radical up. Keep that base. What's that mean? That means, listen. Bump, bump, bump that radical up. Keep that base. It's the exact same answer.
I'm gonna write that on my
Huh?
Does it only work when one is greater? Or would we just
Yeah.
multiply?
Does that work when it's?
5 over the square root of 15. Bump, bump, bump that radical up. Keep that base. I'm done.
Oh.
Because you have to move the radical up and keep the top number though still.
Yeah.
So with the other one, the one basically in front of it because it's a one, it doesn't.
Yep. Oh, wait. Let's really blow this thing out of the doors. 3 over the square root of x plus 1. Bump, bump, bump that radical up. Keep the base. I'm done.
What? That's the base?
Yeah. Whatever's underneath the radical sign's the base.
Also make sure you simplify as well.
Now I can start simplifying if I need to. Like this one, I could take 5 by 15, reduce it down to 3. But the fast way of doing it is the cheerleading cheer, bump, bump, bump the radical up. Keep the base. Works every single time. The only time you would cause problems is if you had the square root of 15 plus something. That's no longer a single radical. So, welcome to day 1 of trigonometry lecture style. We will be finishing this tomorrow and filling out the whole unit circle. You do need to bring it back for tomorrow. Does anybody have any questions? Yes.
For simplifying radicals, you said you could simplify such 5 times square root of 15. I don't really understand that. I think it went out for it.
Yeah, because any extra notes, like they have some.
That's simplified.
Oh, exactly.
Addie!